Okay, I'm going to go over the calculator part of your test review, and these are some kind of typical things that you want to be sure that you know how to do with the assistance of your calculator. Let me take this calculator and shrink the size of it a little bit so I can see this fairly good. Okay, all right, so we're going to do this first group of problems just on the calculator, okay? So what we're doing is an inverse sine on this, and if you read the directions of the problem, it says find the radian answer to three decimal places like that. So that's going to tell you that you need to give me a radian answer to the problem. So the first thing we're going to do is we're going to put ourselves in radian mode, go like that, and then we're going to put in the inverse sine. So we go second. I'm going to clear this off. Okay, we're in the right mode, radian mode. So we're going to go second sine or inverse sine of 0.7054, like that, and then round it off. Okay, just simply knowledge of how to put inverse trig functions on your calculator. Okay, so then what I'm going to do on this is I'm just going to round that off to three decimal places, so that looks like that's going to be written then as 0.783 if we round that off. So that would be the answer to that problem. Okay, now the next one, be sure you study this hard. Boy, students do this one, always mess up on this one. And what I recommend that you do before you even go to your calculator, I mean, you can memorize how to do this, but what you're doing is, this really means this. The meaning of this problem is the secant of some angle theta is equal to 1.5230. If you take the time to write it that way, you got a better chance of doing this right on the calculator. So you can change this to a cosine. So we can say that's the cosine is the reciprocal of that number right there. Okay, then that's going to tell you, if you're going to do this on your calculator, the way to do this on your calculator is to go inverse cosine of 1 over 1.5230. Okay, so we're going to do that. All right, so I'm going to go ahead and put this in the calculator then. So what we're going to have with this is second cosine of 1 over 1.5230, and then we'll round that to three decimals like that. Okay. All right, so we'll write that answer as 0.854, so that's rounded off then, okay? So that's an example of how you would do a basic inverse sine, cosine, or tangent, any of those, okay? Oh, come on, stop this. Okay, all right, so let me pause this for a second and get this fixed. Okay, so that should give you how to do those type of problems, and I just went ahead and did a screenshot to show you how to do that. All right, so now I'm going to put these in. These you just put in exactly the way on the calculator, and then this one says round your answer to four decimal places this time. Now this time it doesn't matter what mode you're in. Okay, so because you're going to do a sine, you're going to do a trig function. This part right here is going to give you the angle, and that can be either in radians or degrees. And if you do the sine of something that's equivalent in degrees or radians, it's still going to give the same measure. So it's okay on these next two problems. You can be in radian or you can be in degree mode. It doesn't make any difference. Okay. So right now I am in radian mode, so I'm just going to leave it there. Okay. So I'm going to clear that off. So I just put it in exactly the way it is. Sine of inverse cosine of 0.7324, like that, double up on the parentheses, then there's your answer. So if we round that to four decimal places, we're going to get 0.6809 as an answer to that problem then. Okay. Now the next one, what you have to do is, since you don't have a cotangent button, you got to put this in, like on your calculator, you have to put this in basically like this. You have to say 1 over the tangent. That's how you put a cotangent in. Then you put this part exactly the way it is. So now you put in inverse sine 1.67. Now, you're going to get an error on this, and let me explain why. See, when I do this, you can't take an inverse sine of anything bigger than 1, because the largest value of the sine is 1 on a unit circle. The biggest y value on a unit circle is 1, so you're going to get an error. Now, don't write error, write undefined. Okay, so you'll have that sometimes, and don't be surprised if you do get that as undefined. Okay, so that would be an example of each one of those kind of things that you do. I'm just going to do a little quick screenshot on this and just kind of have this as a record to show you how I put that in my calculator. Okay. Oh, come on, mouse. Where are you? Come on, there we go. All right. Oh, come on. Thank you, finally. Okay, so I just wanted to have a record for you of how I put that one in my calculator. Okay, so let's move on to solving an equation with the assistance of a calculator. So that's pretty important. Okay, so we got that. All right, so you want to be sure that you study how to do those basic problems. Those are just calculator problems. It's just knowledge of how to press the buttons. Now this one right here is I want you guys to be able to do a basic trigonometric equation where you have to use a calculator on. Okay, so the idea with this one is the very first thing you're going to need to do is you're going to need to isolate the cosine. So we're going to do 5 minus 3 equals 7 cosine of x. Okay, that's because we are subtracting 3 from both sides. So that's going to be 2 is equal to 7 cosine x. Then I'm going to divide by 7. So I'm going to get 2/7 is equal to cosine of x. Okay. Now, there's several ways you can solve this equation. All I'm looking for is all of the answers from 0 to 2 pi, and I want this rounded to 2 decimal places. Okay. So what you could do on this now, and I do want this to be real numbers, so this is telling you, since I say real numbers, that's telling you I want these answers to be in radians to 2 decimals. So we're going to go make sure the calculator's in radian mode. And really what you have to do is just kind of realize what's going on the unit circle on this problem. This is where students a lot of times mess up on this. So this is a positive number, see. Okay, so that's going to tell you that the cosine is positive in quadrant 1 and quadrant 4. So you have to have that knowledge, of course. So now what we're going to do is we're just going to put this in our calculator like this. We're going to go inverse cosine of 2/7. And then that's going to give us an answer like this, okay, which is 1.28. So our first answer, we're just going to say, after we do the inverse cosine of 2/7, that's going to give x equals 1.28 radians, okay? And that's a quadrant 1 answer, because notice if I go pi over 2 is about 1.5. So this answer is somewhere in this quadrant right here, and that's a 1.28 radian angle like that. Okay, so that would be our first answer, as we just say, 1.28. Okay, now the second answer is just going to be a reference angle that's in quadrant 4 that's going to have exactly the same value. Okay, so you have to be in this interval. So what you have to do is you have to say all the way around the circle, which is 360 degrees, but in terms of radians, that's 2 pi radians minus the 1.28 radians like this. So on the calculator, you're going to have to go 2 pi like that minus 1.28. Okay, and then that'll give the second answer to this problem. So that's going to be x equals, let's just say 5.00. They're supposed to round that to 2 decimal places. So those would be the 2 answers to the problem like that. And you can just put 5 on there if you want to like that. So those would be the 2 answers to the problem. Okay, so that's one way you could do that problem. Now, you can also do this problem totally graphically if you wanted to on the calculator. You could go like this. So you could actually graph both sides and see where they intersect if you wanted to. Or you could do this. I'm going to do this like this. I'm going to move everything to the left side of the equation. So I'm going to put in 7 cosine of x plus 3 minus 5 equals 0. So what I'm really doing on this problem, if I want to do it this way, is I'm just saying 0 equals 7 cosine of x plus 3 minus 5. So really that is 0 equals 7 cosine x minus 2. So let's just put it in like that then. So 7 cosine of x and then minus 2, like that. Okay, now you could graph it on this interval. So on our window, we could go 0 to 2 pi. You could scale it however you want to. Let's just scale by pi over 2. That's up to you. And then for the y minimum and max, well, you know you have an amplitude of 7. You also got, a down 2 transformation because we're really graphing this thing right here. So we probably want to make this just go maybe like negative 10 to 10, and that should get everything fit in there, and then scale of 1. Okay, so we have that. So you can graph this if you want to like this, and then if you want to solve this graphically, I would just have you draw out a graph on this. Okay, and then what you can do is you can go like this. If you want to get these answers, you can go second, trace, and then 0. Okay. Then you want to get a left and right bound on this. Stop that. So we want to get the left bound. Like that. Just press the left cursor key until you're a little bit to the left of the 0. Press enter. Press the right cursor key until you're a little bit to the left or to the right. Press enter. 2 triangles come up. You're going to guess. Okay. And then out will come to 0. So that's 1.28. See, that's the first answer that we got anyway, just on the calculator, okay? Then you repeat this again. You go second trace, option 2 or 0. Then you want to get this second 0. So you want to close in, get the cursor getting pretty close to the left of where that 0 is. So you have to press it several times to get it in there. Just get fairly close to it. Okay, that's good enough. Okay, press enter. Triangle comes up. You got a left bound. Right bound, press the right cursor key. Okay, press enter again. You got 2 triangles. So we've established boundaries. So we press enter. And then the second answer comes up, which is 5. And that right there, that's 1 times 10 to the negative 12. For all practical purposes, that's very close to 0. So you can do it graphically like that if you want to, and just solve an equation totally graphically, and just sketch out a graph like that if you want to. Okay? All right, so that's how that goes. The other thing that you could do is if you solved it like this, okay, like the way I put on the paper, you could also just trace out the answers to check. So you could go trace 1.28. Okay, that proves that that's a right answer. Then you could do trace 5, and then that'll take you to that intercept, so it proves that's an answer. Okay. Okay, now let's go to the next page, and this is a real short thing. So another thing I want you to be able to do is to be able to do this kind of a thing, write the equation of a cosine or a sine with the following graph, okay, on this. Now, I did one of these. I think this is pretty much the same problem that I did on the previous page. So what I'm going to do is instead of that, I'm going to do a sine wave this time and just do this differently. So you can use your calculator to do this. So I want to show you a couple of ways that you can do this. So first of all, you have y equals amplitude A times the sine of omega times x minus phi plus something like b. Okay, of course, A is the amplitude. Omega is not the period, but it's a part of the period. That's the phase shift. That's an up-down transformation like that. Okay? So the first thing we're going to look at, if we're going to do a sine wave, I'm going to show you how to do it just kind of mechanically. And then I'm going to show you how your calculator will do this automatically for you anyway with what's called a sinusoidal regression equation. Okay, so when we find the amplitude is 1/2 the max minus the min. Okay, like this. So the maximum is 5. The maximum y value is 5. Okay, the minimum y value is -1. Okay, so that's going to give 1/2. That's supposed to be a half. 1/2 of 6. So that's equal to 3. So what's going to plug in for the amplitude on this is 3. Okay, so it's just half the distance from 5 to -1. That's what the amplitude is. It's half the distance of the crest of the waves. Okay, now the period on this can be from, you can start from here to here. You could just kind of think of the period basically as looking at this point, and then it reaches a midpoint. Okay, that would be like your midpoint, your minimum, back to your midpoint, and then to your maximum. So those are your 5 key points. So the width of that shape is 4. So what we would do on this is we would say, we'd solve this equation like this. We have the formula that says the period is 2 pi over omega. The period's 4. So what we're going to do is we're going to cross multiply this out. So that's going to be 4 omega equals 2 pi. Then we can divide by 4. So that's going to give omega equals pi over 2 when you reduce that then. So what's going to go there is pi over 2. Okay. Now, if we're doing a sine wave, I wanted to do a sine wave on this because it has a phase shift on it. Okay, a sine wave generally the midpoint is what gets phase shifted. Okay, so if you think about this, a basic sine wave is going to start at 0, 0, and here's the midpoint right here. Okay, that midpoint is that point 0, 0. Okay, because how does a sine wave go? It starts at 0, 0, hits its max, then goes like that. Okay, so if you look at this point right here, this thing has phase shifted to the left 1 unit. So what we're going to put there is we're going to put a 1, and since it's going to the left, we're going to make that a plus like that. And then that midpoint right there has clearly moved up 2 units like that. Okay, so again, look at the midpoint. What I'm trying to get you to see is this would be like there. Okay, that would be like the original point of the sine. Okay, then it would cycle to its max and so forth. But that point right there has moved to the left 1 and up 2 like that. Okay, so then the final answer to the problem would be written as y equals the amplitude 3 times the sine of pi over 2, x plus 1. You do have a phase shift that's left 1. Now there's more than one way to write the answer to this problem. You know, you can do a different phase shift on that if you want to like that. Okay, so that's kind of how that goes. Now, there's a couple of things you could do in a testing situation. You could go ahead and put in your answer if you wanted to. You have 3 times the sine, and then you could put in, the best way to do this is put in 2 parentheses, and then just put in pi over 2, close the parentheses, then a new parenthesis, and then put in x plus 1, like that. Okay, and then that would we need to double up on the parentheses, then put a plus 2 in. And for the window, just kind of do the window like we have here. Go -8 to 8 by a scale of 1, be in radian mode. And then the y's look like they're going from we could say -6 to 6 if we wanted to, like that. So if I graph that, if I have a correct graph on there, it should give me exactly what I just graphed there. Okay, it looks like it does. Okay, like that, so that matches up and everything. But another thing that you can do on these problems like this, now the sinusoidal regression could be done if you just put in like 5 points. Okay, if you put in all 5 of those points, you could also do that on your stat. You could go through and put in, just kind of locate 5 points from this graph. Now, it might give you a slightly different answer. So what I'm going to do is I'm going to go up and I'm going to clear all my data. And you can also take this approach if you want to, just purely technological approach. So if you were to go through and look at finding points, okay, this is a point right here. That's going to be a point 0.5. So we could put that in the calculator like this, 0, and then go over to y2, and then put in a 5, like that. Okay. Now this point right here is going to be the point 1, 2. So you could put that in. 1 there, and then 2 there. Just kind of get 5 key points on here is probably a good way to do this. And then this point right here is going to be the point 2, -1. So I'm going to put that in. Okay. And then that should give you enough information on there because you've got a max, a midpoint, and a min. I'm going to go ahead and put this point in, which is, that point right there is the point 3,1. So I can put that in. Okay, and then let's put in this end point right here, which is 4, 5. You're back to the max like that. So let's put that in. Okay, so what I'm doing is I'm taking the 5 key points that you can identify from your graph, like that. And now what I'm going to do is this. Okay, I go to my Stat button. Okay, then I go to Calc. Then I got to scroll down until I find Sine Regression. There's Exponential, Logistics, Sine Regression. Get that to come out, press Enter, and it'll take it a while to figure this out. Okay, so basically it's going to give a slightly different answer than what I did there. But it's pretty close. Notice that A is, they're given 3.1. B, they're given that as, that's a little bit less than that value right there. They give a phase shift. They're given a slightly different answer on this problem. Now, one thing I'd have to make sure on that is I want to make sure that I have the right data put in there. And then that should give a valid answer to the problem. Okay? Okay, I think maybe I put one piece of data in there wrong. I think I had, you need to have 0, 5, 1, 2, 3, 2. Yeah, that point right there is 3, 2 is what that should be. Okay, and then you're going to put in 3, 2, and 4, 5. So let's try again. Stat, Calc, then go down to Sine Regression. It should give the same thing. Okay, that answer didn't make that much sense. It was close. So there we go. Okay, so that's perfect. Okay, notice you've got A is equal to 3, so we got that for the amplitude. 1.57 is what pi over 2 is. Okay, and then the C, see, they're doing this in a non-factored form. So what they're doing on this is they're writing the answer as pi over 2 times 1, because that's not in a factored form, and then plus 2 like that. So you could do that problem with a graphing calculator if you just find the 5 key points. So you can do it that way too if you want to. Okay, then this last problem is just graphing. Generally on a tangent, cotangent, I just generally on these things have you graph and then show the asymptotes. But you can do this totally without a calculator if you want to. So you have y equals 2 tangent of 0.5x. Okay, so we're going to put this in radians. I've already got the graph kind of put together for you. So I'm going to clear this off, and I'm going to put in 2 tangent of 0.5x. Like that. Let's see, we're going to go, the window needs to be adjusted from -2 pi to 2 pi. Okay, and then by a scale of pi over 2. Our tangents are usually better to do by pi over 4. Okay, like that. And then let's go -6 to 6 like we have there. Then we can sketch out the graph. Now this one's got a period change on it, so what you would kind of have is this. Now I'm going to go ahead and just do the same thing, readjust this window so it'll match this graph. So I'm going to have, for my x scale, I'm just going to go ahead and put pi over 2 because that's the way the graph that I gave you did. Okay. Then we'll graph this and just get some key points. So the first thing is we need to identify the asymptotes. So it looks like we have an asymptote at pi and -pi. So we're going to go ahead and put vertical asymptote through pi and a vertical asymptote through -pi, like that. That'll identify that, and then we're just going to get enough good values on this. Now what I'd do is I'd trace on some of these key points. So if I traced at pi over 2, notice I'm going to get 2. So you have pi over 2, and then that's going to be a 0.2 like that. Okay, if you trace at 0, you can even do a table of values if you want to, then that's a 0.00. You can trace at -pi over 2. Okay, and then that'll give -2. And then you can go through and just kind of sketch in the graph like that. Now, we learned how to do this without a graphing calculator, but oftentimes I like to have you just do a tangent on a graphing calculator. So now if you moved over here, you'd have a point that like this. So you'd have that graph. If you moved over here, you'd have a point, 2 points like this. So you'd have the period in the middle, and then you would have that. Okay? So another thing that I typically have students do sometime is write the equations of the vertical asymptotes. So we have vertical asymptotes at pi and negative pi on this problem. And basically the period of this, you would end up having the period would be pi over 0.5. That's really pi over a half. So that's pi divided by a half. So that's pi times 2 or 2 pi. So this period's 2 pi. The distance from negative pi to pi is 2 pi. So we have that. So that means the next asymptote after pi would be at 3 pi. It would be 2 pi later. And then it would be at 5 pi and so forth. So for the equation of the vertical asymptote, we would say x equals k pi, where k is an odd integer. Okay, like that. That's how you'd write that out. Okay, so that would be a tangent graph or a cotangent graph. I'm going to have you usually do those with a calculator. Okay, so that will close off all the problems on this sample test then, and hopefully this will help you to go over some problems to get prepared for. These are the typical kind of things that I expect students to do with the assistance of a calculator. All right, so I hope this helped you, and that'll close us off for this presentation.